Hi, dear students. I have here more example about the behavior of polynomial functions. And let's see. Here we have the first example says x to the third minus 6x to the second plus 11x minus 6. This is in green color. Look, I want you to see first of all which is the degree. The degree is a third degree function, and then the leading coefficient is a positive one. So remember, when we have when the degree is an odd number and the leading coefficient is positive, the graph is falling to the left, as you can see here, and it is racing to the right. And also, I want you to start checking how many roots are we going to find when we talk about polynomial functions. In this case, if the degree is a third degree, we are going to find 3 roots. Look, I want to show you. Here we have the first root, which is 1, 0, the second one, which is 2, 0, and the third one, which is 3, 0. So here you have the 3 roots. In this case, dear students, the roots are real number roots. You could find complex number roots, which are not going to be plotted over the x-axis, as in this case, okay? Let's continue checking more examples. I'm going to hide this one, and I'm going to show you the next one. Now, look, we have x to the third minus 3x to the second plus 4. Again, the degree of this function is a third degree function, and then we have the leading coefficient, again, is a positive one. And look, here we have the same behavior. It is falling to the left and it is racing to the right. But I want you to focus now in the roots. Look, we have here one root, which is minus 1, 0, and here we have another one. But look, dear students, remember, when the behavior is like this one, when it is bouncing and it is not crossing, it's because the root appears twice. So we have this root twice. It says that the multiplicity of this root is 2. Okay? Don't forget about this. So here we have one root and here we have 2 roots. That's why we have, in the end, 3 roots. And I also wanted to show you, for example, if in this case we change, instead of a leading coefficient positive 1, we change it into a negative 1. Look what is happening to the behavior of this polynomial function. It is racing to the left and it is falling to the right. Okay, look again. I am going to raise the negative and I'm going to convert it into positive leading coefficient again. And look, now it is falling to the left and racing to the right. Careful, dear students, pay attention so you don't have any mistake in the activities. Good. Now, let me hide this example and I'm going to continue showing you the next one. Look, again, the degree of this polynomial is 3 because we have minus 6x to the third. And the leading coefficient is minus 6. So that's why, let me show you a little bit better so you can see everything here. Good. Now, you can see it better. Look, it is racing to the left and it is falling to the right. Why? Because the leading coefficient is negative. Okay, and the degree is an odd number. In this case, it is a third degree. How many roots? As the degree is a third degree, we have to get 3 roots, as you can see here, 1, 2, and 3. We could find roots that are not integer numbers, and also we could find roots that are complex number roots. Let me show you, in a while I'm going to show you an example where we have this is an example where we have complex number roots. Look, dear students, in this one we have, it is this one. This is 2x to the third plus x to the second minus 6x minus 8. As you can see, the degree is a third degree function, and we have a positive leading coefficient. So the behavior is going to be this, as always. It is falling to the left, it is racing to the right. But you're going to say, teacher, but we just have one root here. But no, yes, indeed, this is one root. But we cannot see the other 2 roots because the other 2 roots are complex number roots. Later on, I'm going to teach you how to get the complex number roots and the real number roots, okay? But for now, I just want you to realize that you could find a real number roots and complex number roots in a polynomial, okay? Let's continue studying the behavior. Here I have more examples. I'm going to hide this one and I'm going to show you the next one. And we have x to the 4, dear students, which is the highest power that we have in this polynomial. So the degree in this case is a 4-degree polynomial and the leading coefficient is positive. So as you can see, let me show you here. Here you have it. Look, it is the behavior. I'm going to do it smaller so you can see it better. The behavior is, here you have it. Good. It is the green one, okay? The behavior, it is raising to the left. Look, why? Because the degree is an even number, okay? And as the leading coefficient is positive, it is raising to the left and it is also raising to the right. As when we have a positive leading coefficient in a quadratic function, because the quadratic function is also even number degree, okay? Now, you're going to say, okay, and how many roots? As the degree is 4th degree, we are going to find 4 roots. Let me get closer here. So you can see that here we have the 4 roots, 1, 2, 3, and 4. In this case, the 4 roots are real number roots, okay? Let's continue checking the next example. I'm going to hide the previous one. And in this one, dear students, let me get closer. Well, first of all, let's see the behavior. Again, look, when we have an even number degree, in this case 4th, and the leading coefficient is positive, the behavior is this. It is raising to the left and it is also raising to the right, as in the parabola. When the quadratic function we have a positive leading coefficient in a quadratic function, the parabola opens upwards, okay? This is not a parabola. This is a 4th degree polynomial, but we can compare both of them so you can remember about the behavior, okay? Now, let's see about the roots. As the degree is a 4th degree polynomial, we have to find 4 roots. And let me get closer so you can look at them. Here. Look, dear students. Closer, closer so you can see them better. Good. Look. Here we have them. But I want you to focus in this behavior. Here the graph is bouncing, okay? So remember that when it bounces, it's because this root appears twice. So we have this root. This root has a multiplicity of 2. And then here we have another one. So here we have 1 and 2 roots, 3 and 4. Okay, so careful with the behaviors because later on you are going to be asked to plot graphs applying the behaviors depending on the multiplicity of the roots that you find. Okay, careful. Let's see another example. This one, this one. Good. And now it is x to the 4 minus 2x to the third minus 6x to the second minus 7x minus 4. Again, the degree is a 4 degree and the leading coefficient is 1. But let me show you in this one, what are we getting? I'm going to do it smaller so you can see. Look, how many roots can we see here? Let me get closer. Well, first the behavior. As this is an even number degree and the leading coefficient is positive, it is raising to the left and also raising to the right, as you can see. Now, let's check the 4 roots that we have to find. And let me show you here. Good. Look, here we have 1 root, just 1. The multiplicity of this root is 1 because it is crossing, remember. And also the other one is crossing, so 1. Here we have 2 roots. And you're going to say, teacher, but where are the other 2 roots? remember, if we cannot plot them here, it's because they are complex number roots. So we have two real number roots and two complex number roots in this case. Okay, let's continue checking other two examples that I prepared here. In this case, the degree, look, dear students, the degree of this polynomial is a fifth degree. So how many roots do we have to find? 5. Look, first the behavior. As the degree is a fifth degree and the leading coefficient is positive, it is falling to the left and it is raising to the right, as you can see. Okay? Now, let's focus in the number of roots. Let me get closer and closer so you can see the behavior of the roots here. A little bit closer here. And let me show you. Here we have, as we have to find 5 roots, check. Here we have 1, the first one. 1. And then how many roots do we have here, dear students, in the origin? As the graph is bouncing in this point, that means that here we have the same root twice. So this root has a multiplicity of 2. So we have 1 here in the left and 2 more here. So we have 3. And then 4 with this one, which is crossing. Remember that if the root is crossing, the multiplicity of this root is 1. And also here, and also the first one. So here we have 1, 2, 3, 4, and 5. And there you have the 5 roots. All of them are real number roots in this case. Okay? Now, let's see the behavior of the last example that I prepared. And check, dear students, the degree of this polynomial is a 6th degree. And the leading coefficient is positive. So first of all, let me get further so you can see the behavior. Okay, look at this. This is a 6th degree, which is an even number. And as the leading coefficient is positive, it is raising to the left and also raising to the right, as in the parabola. Always remember, as the parabola is a quadratic function, but this is a even number polynomial, an even number degree polynomial. When the leading coefficient of the parabola is positive, the parabola opens upwards. That means that it is raising to the left and raising to the right. It is the same thing here. The degree of this one is 6th degree, which is an even number. And as the leading coefficient is positive, it is raising to the left and also raising to the right. Okay? Now, let's focus in the roots. How many roots, dear students, do we have to find? Teacher, we have to find 6. Okay? So, let's find them here in the graph. Look, dear students, here the first one is bouncing. So which is the multiplicity of this root? 2. So here we have 2 roots. And then the next one, as this is crossing, the multiplicity is 1. So 1, 2, 3 here. And then here we have another root, 4, because it is crossing. And then here we have, let me count again, 1, 2, 3, 4, 5 here, because it is crossing, and 6, the last one, okay? If when crossing, you can see that it is flattened, it means that the multiplicity is, for example, not an even number multiplicity, but an odd number multiplicity. It could be 1 or 3. If the multiplicity is 3, the parabola is going to get flattened here, and then it continue crossing, okay? But here I don't have that example, but we are going to talk about that later. Okay, dear students, I hope it could help you to understand the behavior of polynomial functions, and let's continue studying about them because this is a very interesting topic. Take care, please, stay at home, and have a great day. Bye.